Okay, I'm going to add just a little bit more to this section 2.2 because I want to make sure I explain piecewise functions to you. A piecewise function is where you put 2 or 3 or 4. You can do more than 2 functions, but you basically take 2 functions and you put them together, and they actually change at a particular x value from one function to the other function. So this is the way you write a piecewise function. F of x equals the function 3 if x is less than 2, and it's equal to the function 2x minus 1 if x is greater than or equal to 2. Now the way you evaluate a piecewise function is pretty simple. You can plug some x values in. Like if I plug -2 in, first of all I got to determine which one of these functions does it go with. So I have to decide, is -2, is it less than 2 or is it greater than or equal to 2? Well, since -2 is less than 2, it goes with this function. So when x is -2, I'm just going to get the constant 3. And then I'm just kind of randomly picking some x values. How about x equals 0? Is 0 less than 2 or greater than or equal to 2? Right, it's less than 2, so you'd plug 3 in again. And then what about 2? Well, 2 is not less than 2. It is greater than or equal to 2. So I actually plug 2 in to here. Now I do end up getting the same number as I would if I plugged it in up there, but that's not always the case. So I plug 2 in here and I get 4 minus 1, which is 3. And then if I plug 4 in, I get 7, and if I plug 6 in, I get 11. Well, some strange things will happen if you were to plug these in on the graph, but let me show you graphically what's going to happen. Okay, so y equal 3. Let me show you where x equal 2 is. This vertical line basically is where x equal 2 is. Okay? So y equal 3 would be a horizontal line. So it'd be this right here. But you're only supposed to graph this line up to 2, because remember it said y equals 3 if x is less than 2. So you're only going to get this portion over here. You're not going to get the portion to the right of 2. You're only going to get the portion to the left of 2. Okay? Alright, now, what about the other one, 2x minus 1? Well, 2x minus 1 looks like this. Okay? But 2x minus 1 is only graphed if x is greater than 2. So you're only going to get the points where x is greater than 2. So you're only going to get these points. Well, then when you put that together, your graph's basically going to look like this. On the left of 2, you're going to have this horizontal line, and then when you get here, you're going to draw this. And so when you put those two pieces together, here's what it's going to look like. You'll see down here, I've got a horizontal line, and then when I hit this point 2, 3, I'm going to start going up. I change graphs. Okay, so I go from y equal 3, and then when I get x equal 2, I switch over to this graph, and I follow this graph. And the reason that piecewise functions are utilized is because it turns out that, you know, the relationship between two variables might be one thing for a while, and then once the number changes, or maybe the number gets bigger, like for instance here, maybe the relationship here is that y does always equal 3 when x is less than 2, but once x gets greater than 2, then the relationship changes, and so y is always equal to 2x minus 1. So in other words, maybe the y value starts increasing once x is greater than 2. So sometimes one function can't describe the whole pattern, and you need more than one function. Here's another example. Here I have f of x equals x squared if x is less than 0, and absolute value of x if x is greater than or equal to 0. Well, if you plug -2 in, that would be less than 0, so you would square it and get 4. If you plug -1 in, that's less than 0, so you square it and you get 1. If you plug 0 in, well, that's equal to 0. Let's see. So you plug it in here and get absolute value 0, which is 0. Again, you're actually going to get the same value you would have up there, but I probably should have done one where that didn't happen, because that's not always the case. And then if you plug 1 in, 1 squared is 1. I'm sorry, absolute value of 1. I should be looking here. That's important. So 1 is greater than 0, so I go to absolute value of 1, which is 1. And then when I plug 2 in, 2 is greater than 0, so absolute value of 2 is 2. So those are some points that would be on this function. But if you wanted to actually graph this function, what you could do is, let's get rid of these guys. Okay, so the function said that if x is, here's x equals 0. It's really just the y-axis is all it is. So that's x equals 0. Now, if x is less than 0, you graph this function. Okay? So basically, since this is x equals 0, this function is only graphed if x is less than 0. So you would only get this side. So you would only have this side of that function. Okay? And now for the other function, you only graph it if y is greater than 0. So you would only have this side of that function. So when you put it together, it's basically going to look like this. Now watch close. You're going to have, to the left of 0, you're going to be on the parabola. Okay? And then when you get to 0, you're going to change trains here, and you're going to get on the absolute value function. Okay? And so if you put it together and remove the stuff that's in the way, it looks kind of like this. Forgive me for not drawing a real pretty parabola here, but you've got the parabola coming down like that, and then when you get to 0, 0, you change trains and you get on that absolute value function. So that's what it looks like. And that's basically what a piecewise function consists of. 2 or more graphs for that break at a particular point.